Key concept 12, target A.
Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
A lot of the material covered in Key Concept 12 will be similar to the material in Key Concept 11. The biggest difference is that we're going to be introducing imaginary numbers. So imaginary numbers, if you recall from class, it's when you have a negative value underneath the radical. They introduce imaginary numbers because currently in the real numbers, you have to consider a number that multiplied by itself would give you something that is negative, and there was no such number, so that's why the introduction of imaginary comes through. So first thing we're told is that I is a symbol used to represent the value of the square root of -1. Okay, we're going to write our answers in complex number standard form, which is a plus bi, where a is the real part and bi will be the imaginary. Okay, just so like when we combine like terms, there was a specific order. It's the same when you're dealing with real and imaginary numbers. So, example 1. Find the sum of the following expression. So looking at A, we have the quantity -14 plus 12i plus the quantity -4 plus 8i. If you'll notice in front of the first set of parentheses, there's no known value, so we know it's a 1. Multiplying or distributing everything inside by 1 won't change anything. If we look at the second set of parentheses, out front there's a positive 1 as well. So same thing, multiplying by a positive 1 won't change the values inside. So we can rewrite the entire thing, just eliminating the parentheses. So we have -14 plus 12i, and then we have -4 plus 8i. Okay, and then from there we're just combining like terms. Anything that has an I will be grouped together. Anything that's a constant will be grouped together. So we have -14 is going to group with -4, positive 12i with a positive 8i. Keep in mind we want to write it in a plus bi format, so we want to combine the real numbers first. Real numbers are going to be -14 minus 4, which is going to give us -18. And then the imaginary parts, 12i plus 8i, is going to combine to give us a positive 20i. And that will be my final answer for A. Looking at B, same concept. We have the quantity 4 minus 10i plus the quantity -6 plus 2i. Again, in front of both sets of parentheses are just positive 1, so distributing a positive 1 won't change anything. So we're allowed to just rewrite minus the parentheses exactly how we see it. And then we're going to go ahead and shape it up. Positive 4 will combine with the -6. -10i will combine with a positive 2i. Again, we want to write it in complex format, which is the imaginary goes last and the real goes first. So 4 minus 6 is going to combine to give us a -2. -10i plus 2i will combine to give us a -8i for the final answer of -2 minus 8i. Example 2. Find the difference of the following expressions. So in the previous example, we're finding the sum, which tells us to add. Now we're finding the difference, which is telling us to subtract. So we have the quantity 24 plus 14i minus the quantity 13 plus 6i. If you look at the first set of parentheses out front to the left, there's a positive 1. Multiplying by positive 1 won't change anything, so we can go ahead and bring down the first set of parentheses as 24 plus 14i. Very similar to what we just did. The biggest difference here now is that there is a -1 in front of the second set of parentheses. So we're actually going to have to distribute that because that will change the values. So we have -1 times 13, which will give us -13. -1 times a positive 6i, which will give us a -6i. From there, it's just like the previous example. 24 will combine with -13 because not only are they both constants, but they're both real. 14i will combine with a -6i because they're both imaginary. And then complex numbers need to be rewritten with the real part first. So 24 minus 13 is going to go ahead and give us 11. And then 14 minus 6 is going to go ahead and give us a positive 8i for a final answer. Okay, taking a look at B, we have the quantity 18 minus 3i minus the quantity -4 plus 9i. Same idea. First parentheses has a positive 1, so we can just bring it straight down, sorry. Second set of parentheses has a negative 1 out front, so we're going to need to distribute. Negative 1 times negative 4 is going to give us a positive 4. Negative 1 times a positive 9i will give us a minus 9i. Then we're going to go ahead and combine like terms. So 18 and positive 4 are both constants and real. Minus 3i minus 9i, both imaginary. Combine the real first. 18 plus 4 will give us 22. Negative 3 minus 9i will give us a negative 12i for a final answer of 22 minus 12i. In the previous examples, we had to find the sum and the difference. Real parts were pretty easy. Positive and negative real numbers we're familiar with. Then we had to look at positive and negative i's, but each of those i's technically only had an exponent of 1. Remember, the exponent is a little number on top that tells you how many times to multiply the base by itself. When we don't see an exponent, we can assume that it's 1. So we were dealing with just I, which is technically I to the first, which we know to be square root of negative 1. Okay. Then we have I squared. So that's going to be I times I. And so that's going to be negative 1 times the square root of negative 1. So all I'm going to go ahead and do is rewrite that under one radical. Negative 1 times negative 1. Okay, so again, I to the square is just I times I, and we know that I is square root of negative 1. So I raised to the second is really just square root of 1 times square root of negative 1. Now remember, our index is 2, so we're looking for pairs. There's one pair, so that can come out, and they both will cancel. All right, so I raised to the second is actually really just negative 1. Okay, I by itself is technically I to the first, which is just going to end up being I. It doesn't get much simpler than that. However, now we know that I raised to the second is going to give us negative 1. Okay, so let's look at what I to the third is. I to the third just tells us to take I times itself 3 times. We know I is square root of negative 1, so that's technically negative 1 times square root of negative 1 times square root of negative 1. Again, put it all underneath the one radical. We have 2 of those, which one will come out. They'll both cancel. We'll be left with square root of negative 1, which we know is just I. So that's really just going to be negative I. So we know I is as simple as it gets. I to the second ends up becoming negative 1. I to the third becomes negative I. So let's see what we have means when we have I to the fourth. I to the fourth is just I times I times I times I. And we know I to be square root of negative 1. So we're just going to go ahead and multiply that 4 times. Okay, put it all underneath the one radical. Here's a pair. One will come out. Here's another pair. One will come out, and whatever comes out gets multiplied together. So negative 1 times negative 1 will give us positive 1. Okay. Now, so far we know that I to the first is just I. I to the second simplifies to negative 1. I to the third simplifies to negative I. And then I to the fourth is just 1. So let's see what happens if we were to do I to the fifth. Okay. Eventually that's going to be 1, 2, 3, 4, 5. Here's a pair. I can take one out. Here's another pair. I could take another pair out. And we'd be left with the square root of negative 1, which we know to just be I. Negative times a negative right here will give us a positive, and we would just be left with I. But that's the same answer that we got for I. So it turns out the powers of I actually follow what's called a cyclic pattern, which means it moves in a cycle. So once it goes from I to I to the second to I to the third to I to the fourth, it then goes all the way back. So I to the fifth would actually be the same thing as I, which means I to the second is the same thing as I to the sixth. I to the third is going to be the same thing as I to the seventh. I to the fourth is going to be the same thing as I to the eighth. And then, of course, the pattern's going to cycle again, which means I is the same thing as I to the fifth, which is the same thing as I to the ninth. I to the second is the same thing as I to the 6th, which is the same thing as I to the 10th. I to the third is the same thing as I to the 7th, which is going to be the same thing as I to the 11th. I to the 4th is the same thing as I to the 8th, which is going to be the same thing as I to the 12th. Okay, so whenever we have exponents of powers, we can actually simplify them pretty quickly. A key here too is you see whatever exponent we're given, we can just go ahead and take those exponents and divide it by 4. And the reason we're going to divide it by 4 is because there's 4 possible solutions of I. So let's say, for example, I were to take I to the 5th, right? I could take 5. 5 divided by 4 would give me the decimal equivalent of 1.25. Okay? The whole number 1 just tells me that it cycles through the pattern one time. The 0.25 tells me that it's going to end up on the first out of the 4 possible answers. So whenever we have a decimal and it ends in 0.25, that tells us it's going to be the same thing as I. Let's see, for example, I to the 6. If we took I to the 6 divided by 4, 6 divided by 4 is going to give us 1.5. The whole number 1 tells us that it cycles through the pattern one time. The 0.5 tells us that it's going to end up on I to the 2nd. Let's say we took I to the 7. 7 divided by 4 is going to give me 1.75. 1 tells me that it cycles through the pattern one whole time, and then 0.75 tells me that it cycles 3/4 of the pattern, which is going to end up being right here with I to the 3rd. Okay, if we took I to the 8th, exponent 8 divided by the 4 possible solutions, it's just going to give us the whole number 2, which means it cycles through the pattern 2 whole times, and it ends up right there. So this will just give us a decimal of 0.0. There will be no remainder because it cycles through the pattern completely. All right. It's a bit of a shortcut. You could always put it into your TI Inspire, but just so you know how the pattern works, again, it's a cyclic pattern, which means once it goes through the 4 answers, it recycles back, it circles back to the first answer that you got, and it'll just keep doing that over and over again. Example 3. Evaluate. Describe the pattern you use to arrive at your solution. So again, this is one of those where you could just do it in your calculator, but I'd rather you sort of know how to do it by hand. We have I to the 26. Now, you could go back to the previous slide with the 4 previous answers, I to the 2nd, I to the 3rd, I to the 4th, and just keep counting until you get to 26 and figure out the pattern. But I told you the shortcut here is to take the exponent 26, and then you're going to want to divide it by the 4 possible answers. Okay, so if you were to go to your calculator and type in 26 divided by 4, you're going to go ahead and get 6.5. Okay, now how that's going to help, let me go back. So we already said that I can't be any simpler, but whenever we divide, it'll give us a decimal of 0.25. I to the 2nd will just give us 0.50. I to the 3rd will give us 0.75. And I to the 4th will give us 0.0. Now remember, I is just I. There's nothing to simplify that. Okay. I to the 2nd is actually going to go ahead and give us -1. I to the 3rd is actually going to give us -I. And I to the 4th is just going to give us a +1. Okay. Now, the whole number 6 tells me that it cycles through the pattern 6 times, but then it lands on 0.5, which is going to be the same thing as I to the 2nd. So I to the 26 is the same thing as I to the 2nd, which is the same thing as -1. That'd be the final answer for A. And then it says describe the pattern. You take the exponent, you divide it by the 4 possible answers. The whole number 6 tells you that it cycles through the pattern 6 times. And the 0.5 tells you that it cycles through the pattern 1 more time, but only halfway through. All right, looking at example B, we have I to the 32nd. We're going to, again, take the exponent 32, divided by the 4 possible solutions, and we're going to get 8, which is the same thing as 8.0, which means it cycles through the pattern 8 whole times, and then it ends. It lands on I to the 4th. So I to the 32nd is really just I to the 4th, which is just 1. Okay, so again, describe the pattern. I took the exponent 32, I divided it by the 4 possible solutions, I got the decimal equivalent 8.0. The whole number 8 tells me that it cycles to the pattern 8 times before landing on I to the 4th, which is really just 1. Looking at I to the 13th, we're going to take the exponent 13. We're going to divide that by 4, the 4 possible answers. We'll get a decimal equivalent of 3.25. The whole number 3 tells me that it cycles through the pattern 3 whole times. And then on the 4th time, it only gets a quarter of the way there. So it's going to land on just I, which there's not much we can do. It's just going to be I. Then the last one we're looking at, I to the 19. Again, take the exponent 19, divide by the 4 possible solutions. Okay, so again, you're going to do 19 divided by 4 decimal point. You're going to get 4.75. The whole number 4 tells me that it cycles through the pattern 4 whole times. The 0.75 tells me that on the 5th time that it's going to cycle, it only gets 3/4 of the way there, which is just going to be I to the 3rd, which is the same thing as a negative I. Final answer. Example 4. Find the product of the following expressions. So we were just doing sum and differences before because we were only dealing with i's to the exponent of 1. But now if we're going to do product, we're going to be thinking about multiplication. And if we're multiplying, you should be thinking the exponent law of multiplication, which says if they have the same base and they're being multiplied, you're going to add them together. So negative 2i times 7i, we can multiply the coefficients together. Negative 2 times 7 is going to give us negative 14. And then we have I times I. They have the same base I. Technically, they're both being raised to the first, so we're going to go ahead and leave the base the same, but we're going to add the exponents together. 1 plus 1 is going to give me 2. Now, that does seem like the final answer. However, we know that i's raised to any exponent can be simplified a little bit, right? So right here in the middle, I'll just put for reference. Remember, I was as simple as it got. I to the 2nd, when we broke it up, ended up just being negative 1. I to the 3rd ended up being a negative I. And I to the 4th ended up being a positive 1. So right here, where we see I to the 2nd, we can actually replace it with negative 1. So negative 14. I to the 2nd gets replaced or substituted with the value negative 1. Negative 14 times negative 1 is going to give us a final positive answer of 14. Alright, these are a little bit different. We need to multiply everything in the first parentheses by everything in the second parentheses. So we'll start with 5. We'll do 5 times negative 4 is going to go ahead and give us negative 20. 5 times positive 8i will give us a positive 40i. So we took the 5 in the first parentheses and multiplied it by everything in the second set. Now we're going to take positive 6i and do the same thing. We're going to multiply by everything in the second parentheses. So 6i times negative 4 will give us a minus 24i. And then 6i times a positive 8i will give us a positive 48i to the 2nd. Careful. We can multiply the coefficients together, but when we do I times I, they have the same base. So thinking of law of exponents of multiplication, we keep the base the same, but we add the exponents 1 and 1 to get 2. So let's try to simplify this a little bit. Right now, I know I can combine like terms, 40i and minus 24i. Negative 20 is the only constant. 48i to the 2nd does have an I, but the exponents are different. And remember, for it to be considered like terms, they need to have the same variable, the same exponent, or constants get together. So we'll bring down negative 20. 40 minus 24i will give us a positive 16i. And then, keep in mind right here, we have I to the 2nd, which we found out was just negative 1. So we can bring down the positive 48, but we're going to substitute I to the 2nd with negative 1. Okay, that's going to change things a little bit here now. I'm going to bring down negative 20, bring down the positive 16i. 48 times negative 1 will give me a minus 48. So now I just created more like terms that I can combine. I can combine negative 20 with minus 48. 16i will be by itself. Remember, final answer, complex numbers, the real part first. So we're going to go ahead with 20, negative 20, minus 48. It's going to go ahead and give us a minus 68 and then positive 69. And that right there will be our final answers. Example 5a. Describe and correct the error made in simplifying the expression, the quantity 3 plus 5i times the quantity 2 minus 3i. Alright, so it looks like someone did the work for us, but we're told to describe and correct the mistake. So a couple of things they want from us. So apparently there was a mistake made here. We still got to figure out where it happened. Alright, so we're going to take the same expression that they use, the 3 plus 5i times 2 minus 3i, work it out ourselves and sort of see where things went wrong. Okay, so first step, taking 3 times 2, it's going to give me 6. 3 times a minus 3i will give me a minus 9i. So if you look to the left, looks like we're good so far. Now we're going to take 5i times 2, gives me a positive 10i. 5i times a negative 3i is going to give me a minus 15i to the second. Positive 10i minus 15i to the second. Looks like so far the first step, is correct. So moving on to the next one. What can we do here? We can combine like terms. 6 is going to go by itself. Negative 9i with 10i. And then I squared can be replaced with a negative 1. So we'll try to do all that in one step, see what happens. So we can bring down the 6. Negative 9 plus 10i will definitely give us a positive 1i, or in this case just positive I. And then negative 15 times negative 1. You notice here they didn't multiply just yet, so I'm going to wait to do this. I'll bring down the minus 15, replace it with the negative 1. Okay, so it actually looks like so far we're okay. Next step here. Bring down the 6, bring down the I. Negative 15 times negative 1 will give me a positive 15. So actually looks like we're good so far. And then the last thing is going to be combined like terms. The constant 6 can go with 15. I will have to go by itself. We do the real part first. 6 plus 15 will give us 21, and then just bring down the I. So this last step is where the mistake happened. It looks like they try to combine everything together. So they try to do 6 plus 1i plus 15 and say it was 22i. But remember, I, think of it sort of as a variable. It does represent something. We do know what it represents. It represents the square root of negative 1. But we still cannot combine it with the constant 6 and 15. So final answer is right here. And then it does say to describe. So you could, in words, in a sentence, say, the mistake occurred in the very last line. They tried to combine 6i and 15 together when they were not like terms. The real answer should be 21 plus I.